All right, AI SL2. Today I have a couple more examples of how you could apply integration. So last class we talked about applications of derivatives. Today I'm going to talk a little bit about integration. So this first one is find the area under this curve, and that curve is modeled here with this parabola with respect to the x-axis. So I shaded the area that we're trying to find. The first thing I notice about this is I don't really know what these x-intercepts are. There's two ways you could go about this. If you're going to go full graphing calculator, you could just graph it and use the zero function to figure out what those spots are. Or if you want to go the algebraic route, you can take the original function and set it equal to 0. This will tell you what your x-intercepts are. Now, algebraically, if you're going to factor this, I don't like that negative out front. So I'm going to divide both sides by a negative and get x squared minus 8x plus 12. Now, that means we need two numbers that multiply to 12 and add to negative 8. I believe those are negative 6 and negative 2. So we get negative 6, negative 2. And then when you set both those parentheses equal to 0, you get x equals 6 and x equals 2, which means those are the x-intercepts. Now, if you want to find the area underneath that curve, you need to do an integral from 2 to 6 of the function negative x squared plus 8x minus 12 dx. Now, if, once again, we're allowed a graphing calculator, you can pretty much straight punch this into your graphing calculator with using that fnint function, which we've covered before in other videos. If you wanted to go algebraically with it, you could take the antiderivative of the inside. So the antiderivative would be rolling it up one, so negative 1/3 x cubed, plus rolling it up one, dividing by 2, 4x squared minus 12x, and then you're going to run it from 6 to 2. Now, I haven't really used this notation much in this class because we haven't done a lot of things algebraically. But what this means is you're going to plug 6 into the function and 2 into the function and then subtract them. So this would be negative 1/3 6 cubed plus 4 times 6 squared minus 12 times 6. Then minus a big, the whole function with 2 in it. Now, at this point, I would probably reach for my calculator and then punch in negative 1 divided by 3 times 6 to the 3rd power plus 4 times 6 squared minus 12 times 6, and then do a big minus and a big parentheses to put the whole second half of that in a parentheses. So negative 1 divided by 3 times 2 cubed, which is 8, plus 4 times 2 squared, which is 4, minus 12 times 2, and close your parentheses. So I believe this whole thing is equal to 10.666 repeating, which is not approximately, but exactly equal to 32/3. Then I would probably go into math and use fnint to check my answer. I mean, this all really depends on whether or not you're allowed a full graphing calculator or not. So I'm punching the original thing into fnint. Yeah, it's the same thing. When you use fnint, this is also 10.666 repeating. So that's the area underneath the curve, 32/3. Next up, this is a problem fresh off the IB exam that just happened a few weeks ago. So they say there's a lot more flavor text in this, but I kind of boiled it down. They gave you this diagram right here and said a painting is placed on a coordinate axis. The curve is modeled by y equals f of x, and the horizontal line is the x-axis. So this is the x-axis, which makes sense if, like, if you were to draw the graph and continue it, that this would be negative 1, 1. Oh, that means that the y-axis isn't really shown. So the hard part of this is just interpreting what you're looking at first. Then they say use the trapezoidal rule with this table to approximate the shaded area. Now, when we learned this chapter on integration, the trapezoidal rule seemed out of left field, and I don't think we focused on it too much, and then lo and behold, it comes up on the IB exam. I mean, we did problems and homework problems with it, but I did not expect it to be on the IB exam. So, to use the trapezoidal rule, we're going to do area equals 1/2 the width of the intervals, which the width of the intervals are going up by 1 here. So this will be 1, and then times, it's like the first height plus the last height, and then double the in-between heights. So this will be 0.6 plus 0 plus 2 times 1.2 plus 1.2. So then reach for our calculator and punch all that in. We get 0.5 times 0.6 plus 2 times 1.2 plus 1.2. So this is 2.7. And that's an approximation because we're using the trapezoidal rule. So basically what that means is they were like splitting it up into these trapezoidal chunks. So that's at 0, and then this would be like 1, and this would be 2 or something like that. So then you use all the heights of these to like split it up into trapezoids, and then it would be about 2.7. Now, after that, they say the artist used this equation. So this is like an exact equation for that curve that cuts through the painting. They say find the exact area of the shaded region. Well, if we know the actual equation, we can just integrate it using our fn int. So we're going to integrate negative x cubed minus 3x squared plus 4x plus 12 and divide that all by 10 dx. Now, we still need to fill in these spots from where to where. But if you go back up to this diagram, it starts at x equals negative 1 and ends with 2. So those are the numbers that we're going to punch in here, negative 1 and 2. Now, if I go into my calculator and use fn int again, we're going to go from negative 1 all the way up to 2. And then I got to punch in this giant equation and be careful with my parentheses. Negative x cubed minus 3x squared plus 4x plus 12, close parentheses, divide it all by 10, close that parentheses, and then do it with respect to x. So this is about, well, not about, it equals, it's exactly 2.925. So you guys, we were not that far off with our trapezoidal rule. We got 2.7, and with the actual equation, we got 2.925. So very similar. Then it says find the area of the unshaded region. Well, we just found, get rid of this, oh no, that's no good. Okay, we just found, what did an orange? This area right here, which is 2.95. So we need to subtract that from the total square so we can figure out what these leftover gray areas are. Now let's think. This side of this square right here goes from negative 1 all the way to positive 2. So that's a side of 3. And then I think it's the same thing here, that this goes negative 1 all the way to 2. So that's also a side of 3. So that means the area, the total area of the square is 9. So here, basically the leftover is going to be total minus the shaded. We don't know what the leftover is, so we'll just call it A. We do know that the total square is 9, and then we have to take out a 2.925. So 9 minus 2.925 is 6.075 units squared. Adding units squared on everything just to be a good teacher. Okay, you guys, there's that whole problem. Straight off the IB exam. Good luck with your homework.